Welcome everyone. This is the third episode of our involution series and projective geometry. So we were discussing about cross ratios and we saw that cross ratios are defined in three different ways. One, when 4 points are collinear, and other when 4 lines are concurrent, and another when 4 points are concyclic. We see that these three are not very different ways of defining cross ratios. In fact, when you project one onto the other, they are going to preserve the value of this cross ratio. For example, when you have 4 concurrent lines and you project it with a line intersecting all these 4, the thus formed 4 collinear points will have the same cross ratio as that of the 4 concurrent lines. So these 4 concurrent lines form a configuration that is sort of the bridge connecting the cross ratios from 4 collinear points to 4 concyclic points. Now make sure that these 4 concyclic points is formed by a circle passing through the point of perspective. Point of perspective is the point which is the point of concurrency of those 4 lines. So this is just a quick recapitulation of what we covered in the previous few episodes. You may have a look if you missed some of these. The episodes 1 and 2 elaborates on these two ideas. And today we are going to learn about inversion and pole-polar conversion. So first, we will look into inversion, and as we move on or progress through this course, you will understand why inversion and pole-polar conversion are crucial. Let's get started. What is inversion? Inversion is basically defined about a circle or with respect to a circle. So we have the center of circle, say O, and we must also have the radius of circle to define the inversion. Let's say R is the radius. But the configuration is not much dependent on the radius of circle. Only the absolute distances are dependent. The relative configuration is going to be the same even if you change the values of R. So the inversion is defined in the following way. If you take the point P, then inversion of P, that is P star, is the point on the segment OP or the line OP. In a more precise sense, I should say, it is a point on the ray OP such that OP star times OP equal R square. So you are going to get the radius when you multiply the distance from O to the 2 points, to P and to the inverse of P. This means if one is greater than R, the other one is going to be less than R. So as depicted in the picture, OP is greater than R, so OP star should be less than R, and an approximate location of P star is as shown. So if P is inside the circle, P star is going to lie outside the circle by a similar argument. And if P is on the circle, then P star is also on the circle. But since OP is the ray, underlying ray, P star equals the point P, because there exists a unique point where a ray intersects the circumference of a circle. So P outside, P star inside. Then as P comes closer to the center of circle, P star goes closer and closer to the circumference. And when P goes to the circumference, P star also goes to the circumference. And then when P comes inside the circle, P star goes outside the circle. This is how the phenomena of inversion works. Well, what is so interesting here? That's the usual question, right? And by the way, we assume that point O's inversion is the point at infinity. And the point at infinity comes to O. So this point at infinity is some magical point that we append onto the plane. It's not a part of the plane. It's some another magical point that we introduce to make this entire definition coherent. Okay, why is this so helpful? Well, I'm not literally going to discuss that because inversion has several applications either in problem solving or in our discourse or in many other applications. But what it does is that it takes you from one world to another, and that makes it simple to analyze a problem or a configuration. Might be it makes it difficult, but in some problems or in some configurations, it is going to make it really nice and simple. Majorly when many circles concur at a point, it is going to make your life real simple. But it is entirely changed world. Your rules are different. The distances are not preserved. Configurations are not preserved. In fact, invert a circle, you are going to get another circle. That is something like this. But when you invert a circle that is passing through the center of inversion, that is O, then it is going to become a line passing through the intersection of the circle of inversion and the center of inversion. By the way, the black circle about which we invert is called circle of inversion, and the point O is called center of inversion. So these are some weird stuff, but when you get accustomed to these properties, it is going to be not much difficult to perceive the inverted space. Alright, the next thing is the pole-polar conversion. What is a pole and what is a polar? Actually, they are related to inversion. So you again have a circle of reference, that is circle of inversion, and the center of inversion. Let's again call it by the label O. Now, pole refers to a point. Whenever I say pole, I refer to a point. Whenever I say polar, I refer to a line. Now, in this space, in the two-dimensional space, I'm going to associate each point with one line, one unique line. This essentially translates to an association of each pole to a particular polar. And how does this association be defined? Let's take a point P. We know inversion. Since we now know inversion, invert the point P. It will lie on the ray OP, but outside the circle, and we get the inverted point P star. Construct a line perpendicular to OP through P star. That means it should make a right angle at P star to the line OP. Now this is called as polar of P. Let's represent this by LP. And similarly, the point P is called as pole of LP. So now I have defined the polar of a given pole. But you may wonder, can we retrace the pole of a given polar? Yes. By just following a backward approach, you can indeed perform that. That is, you have a circle again and a line. So this is polar of some point. What is that point? Is what we are searching for. Drop a perpendicular. Now I know this is the point of inversion of that pole. So now invert P star to get the original point P, and this is called as pole of LP. This is how you have to convert a polar to pole and pole to polar. There are several properties satisfied by these poles and polars, and particularly this pole-polar conversion. We will see that this pole-polar conversion is going to preserve cross ratio. That is, if you have 4 collinear poles, this will be transformed to 4 concurrent polars whose cross ratio is same as the 4 collinear poles. This will be a part of our later discussion, but one thing to take here is the Lahayer's theorem. This is an essential basics of pole-polar conversion. What does it state? Suppose you have the reference circle again, that is the circle of inversion, and you have the point O, center of inversion. Suppose if a line LQ, say, passes through a point P, then it turns out that pole of LQ shall lie on the polar of P. So we are trying to realize that pole of LQ lie on polar of P. So let's see a quick argument on this. How to construct the pole of LQ, that is point Q? Just drop the perpendicular to get Q star and invert it to get Q. So it will be around here, close to the circumference, because Q star is close to the circumference. Now, how to convert the pole P to its polar? First, join OP, find its inverted point, and then draw the polar by dropping a perpendicular at P star to OP. So if I'm able to prove Q P star P is 90, I would be done. That essentially implies that Q lies on the perpendicular to OP at P star. But it But it is true trivially because OQ times OQ star is equal to R square. That's the definition of inversion, which is also OP times OQ star. So, by the converse of power of point theorem, I get that Q star, Q, P star, P form 4 concyclic points like this, right? These 4 form 4 concyclic points as shown. Let me redraw it clearly. Yeah, it will be like this. Now, this means that angle Q P star P is 180 minus angle Q Q star P. But Q Q star P is by definition 90. So we get that Q P star P is also 90. Therefore, the statement pole of LQ lie on polar of P is true. So we will be utilizing these tools in the subsequent videos. So stay tuned and happy learning everyone. Bye.